This is Note-Taking Guide, Day 11 for Math for Life. Today we're going to talk about expected values. So we're going to start off by just reminding ourselves what an average is. So looking here at this example here, it says there are 5 people standing at a bus stop. The first person has $52 in his wallet. The second person has $12. The third person has no money. The fourth and fifth person have $20 and $30 respectively. What is the average amount of money that a person at the bus stop is carrying? Well, in order to find the average here, we're just going to add those numbers together and divide by the number of people that there were, which is $5. So $52 for the first person, plus $12 for the second person, $0 for the third person, and then $20 and $30 for the fourth and fifth person. We're going to add those together and we're going to divide by 5, and that's going to give us the average amount of money that each one of them would have in their pocket. And if I did that on my calculator correctly, I got $22.80 is the average that they would have in their hands or pockets if they're waiting at the bus stop. Now, when we're talking about average on probabilities, we have to talk about it a little bit differently. So what we're going to do today is talk about expected value, which is really the average of something happening, but dealing with the probabilities. So this chart up here, it talks about if you went into the doctor, this is the number of medical tests that they ran on you. So if you went into the doctor and they ran 0 medical tests on you, then you were fit in 40% of the population. If they ran 1 medical test on you, then you were in this percent of the population, 2 medical tests here, and 3 medical tests here. So what would be the average or expected value of how many medical tests would be ran on you if you went to the doctor? Well, what we're going to do is we're going to do something called the expected value. So the expected value is just like the average, where we add up all the numbers and then we divide by the number of numbers kind of idea. But really right here we already have our probabilities distributed out. We know that 0% of the population are going to have a 40. All right, so what we're going to do in order to find the expected value, or what the average is of the number of tests that you're going to have run on you when you go to the doctor's office, is we're going to find the value of having 0 tests run. So people who have 0 tests run, we would take 0 and we would times it by that 40%. And then what we're going to do is we're going to add it to the next one, just like we would be adding to find that average. So we're going to say 1 test happens 33% of the time. We're going to add that to 2 tests happens 20% of the time. And then 3 tests happen 0.07% of the time. We're going to do the math here, and we're going to figure out what the actual likelihood is that you would have tests ran on you at the doctor's office when you go. What's the expected value of that happening? So when you do this, you'd have 0 times 40, which is 0. And then you'd have 1 times 0.33, which is 0.33. 2 times 0.20, which is 0.4. And then 3 times 0.07, which should be 0.21. When you add those all together, this should be your expected value. And the expected value that I got was 0.94. So what does that actually mean? That means that the average number of tests that is ran on any given person that goes into the doctor's office is 0.94. So pretty much 1 test, because you can't run 0.94 tests on a person. But that's what we just did. We found the average number of tests that was ran on a person by using the data that was given to us. All right, this is how it looks as a formula. This is the sum of all of the x's times their probability of x, which is what we really just did. This is the expected value formula. This symbol right here means sum. So we're adding all of the x's times their probabilities together, which is really what we just did on the other piece of paper on the other example. So let's see if we can do it again without really going into deep detail of what that formula stands for. So here's my next example. It says we have a dice game, and we're going to roll one dice at a time. When we roll a 5, we win $5. When we roll a 6, we win $10, and any other roll wins nothing. So if I roll a 1, then I get nothing. If I roll a 2, I get nothing. If I roll a 3, I get nothing. If I roll a 4, I get nothing. If I roll a 5, I get $5. And if I roll a 6, I get $10. Now I'm going to go and do the probabilities of all of this happening. Remembering this is a 6-sided dice to get those 6 numbers. I have a 1 in 6 chance of rolling a 1, a 1 in 6 chance of rolling a 2, 1 in 6 chance of rolling a 3, a 1 in 6 chance of rolling a 4. We still have a 1 in 6 chance of rolling a 5 and a 1 in 6 chance of rolling a 6. So the probability is the same on these because the dice is fair and it has 6 sides to it. So what I'm going to do now in order to find my expected value is I'm going to multiply these together and add them just like we did on that last problem. Well, 0 times 1/6 is 0. Again, 0 times 1/6 is 0. 0 times 1/6 is 0. 0 times 1/6 is 0. Now 5 times 1/6, if you put that in your calculator, and we want a decimal point number for this. So when you put that in your calculator, you get 0.833 repeated. And then 10 times 1/6 on our calculator, when we do that, we get 1.66 repeated. And then in order to find the expected value or the average number of earnings for a roll of a dice, we're going to add those two together. So 1.66 plus 0.8333. And when you do that, you get really close to 2.5. I'm going to just round that to $2.50. So what this says is it says when you roll a dice, you have a chance of winning or an expected value of $2.50 to win. So this says a game like this is typically not free. Usually you have to pay to play. How much would you be willing to pay? Well, if you're expected to win $2.50 for a roll of a dice, I definitely wouldn't pay more than $2.50 because then you'd lose money. So I would pay less than $2.50. I also, though, would think about the fact that I want to earn some money, though, so I wouldn't want to be at $2.50. I think that I'd want to be quite a bit lower than that for paying in order to actually get a profit. It says if you were running the game, how much would you charge? Well, it would make sense that you would charge more than $2.50 if you're going to be giving $2.50 away on average per customer. So I would say more than $2.50 per game. All right, next example. Now here's a problem that we have up here. First of all, you can't even see what color these were. So on my paper, I'm just going to kind of mark them for you. Blue, blue, blue for these ones. These two over here are yellow. And then I have a red and purple I got to take care of still. So red is up here. And then there's two up at the top that are purple. So these were not shaded well. They didn't have them labeled. So there's my colors for this. So now I'm just going to go and I'm going to find my expected value. So it says this time it cost me $2 per spin of the wheel. So this is going to be a little bit different than what we've been doing because it cost me to spin in the first place. Purple wins 50 cents, yellow wins $5, blue wins $1, and red wins nothing. So the total winnings here on red would be 0. But I want you to think about it for just a minute because it's going to cost me $2 no matter what. So if I roll a red or spin a red on this, I actually am going to lose money because I win nothing and I spent $2 to play. So instead of putting 0 minus 2 right here, I'm just going to put -2 because that's what it's going to cost me to play right there. Let's go and take a look at, let's go just up the chart here and do blue next. If I land on blue, I win $1. but it cost me $2 to play. So if it cost me $2 to play and I win $1 back, I'm really in the hole $1 still. I didn't actually win any money yet. On yellow, it says I win $5, so now I could finally make some money. Because if I win $5 and it costs me $2 to play, then I'm actually up $3. And then on purple, you win 50 cents. But if you already paid $2 for it, you're actually in the hole $1.50, because that's how much money you would lose if you only won 50 cents. So here's my winnings according to the way that it cost me money to play. So now I'm going to go and find my probabilities over here on my spinner, and this would be 8 equal pieces here. So purple would be 2 8s, which would reduce to be 1/4. Yellow would be 2 8s, which would also reduce to be 1/4. Blue would be 3 8s, so I'm just going to put 3 8s because it doesn't reduce. And red would be 1 8. Now I'm going to take my calculator and I'm going to multiply these values together to get my expected values to add together to find what I could expect to win on this spinner game. So I'm going to do a negative 1.5 and I'm going to times it by 1/4. And I'm going to get a negative 0.375 up here on the top. And then 3 times 1/4 is a positive 0.75. A negative 1 times 3 8 is a negative 3.75. And then a negative 2 times 1/8 is a negative 0.25. So if I wanted to know my expected value for playing this game, I would then just add those values straight down and find out what my solution is. All right, when I add those straight down, I get a negative 0.25, which means the average earning per spin of this game is a negative 25 cents. So would you play this game? I would say no. Is this game fair? Absolutely not. If you're gonna, you really don't have a fair chance of winning if the average person is gonna lose 25 cents on this game. All right, so here we go on to the next one. We're playing a marble game this time. We're paying $3 to pull a marble from a bag. If we pick green, we win $5. So green would be, we'd win $5, but we paid $3, so we can put 2 in there on the green. If we pick blue, then we win $1. We paid 3 to play though, so that's really a negative 2 in there. That's not going to get us any kind of profit back out of that, because we're going to lose some money there no matter what. So then on the next one, yellow, we win $2, but we paid $3, so that's still a negative 1. And then red, you win $0, so it actually cost you $3 to play, so you're negative. So this is not looking very promising as being a game that I would want to play, because it's not looking like I have a very great chance of winning. So probabilities, though, of picking a marble, well, they didn't give us like anything that said there was more green marbles than whatever. So we're going to assume that each one of these has a probability equal of 1/4, because there's 4 different colors and they didn't tell us that it wasn't equal probability. So I'm going to multiply these out and I'm going to get my solutions here so that I can figure out my expected value. 2 times 1/4 is 0.5. Negative 2 times 1/4 is a negative 0.5. Negative 1 times 1/4 is a negative 0.25. And negative 3 times 1/4 is a negative 0.75. When I add those all straight down, I get a negative 1. So what that means is that the average person, when they play this game, is going to lose $1. So would you play this game? Again, no, I wouldn't. Is this game fair? Absolutely not. It's not fair, because the average person loses $1 per game. So it didn't really show you a great example today of one that is actually fair, but one that would be fair would be a nice profit happening every single time. Okay, one more example here, I think, and we're done. So a store offers you a scratch-off coupon as you're checking out. The probabilities of each discount amount are listed in the table below. What is the expected value of my discount on a coupon? So this is really nice because it already has it for you. We just have to multiply it out. So we have 25% times 1/5. So I'm going to just change this to 0.25 and do 0.25 times 1/5. And you can just punch that in your calculator and let it do the work. So this is 0.05. I'm going to do 40 times, or 0.4 times 1/50. When I do that, I get 0.008. I'm going to do 1/100th times 0.5. When I do that, I get 0.005. And then 0.75 times 1/1000th. And I get 0.00075. Now it said here all other coupons are for 10% off. So what I need to do is I need to add these up and see how many people, or what the percentages of people that are not getting any coupon at all, or the coupon I should say for 10% off. So I'm going to add the 0.5 or the 1/5 together, plus the 1/50th, plus the 1/100th, plus the 1/1000th, and that's going to tell me how many. So that added up to be 231 out of 1,000 if I add those straight down right here. Now all other coupons are for 10% off, which means if I took this 231 out of the 1,000, then that means I have 769. So this probability right here would be 769 out of 1,000 get 10% off. So 769 out of 1,000, and I'm going to times that by 10%, which is a 0.1, which gives me a 0.0769. Then I'm going to add those straight down together to get my actual average percent off. So 0.05 plus 0.008 plus 0.005 plus 0.00075 plus 0.0769. And when I do that, I need to check this one more time. So when I added those straight down, I got 0.1474. If I change this back to a percent, I'm going to move that decimal point 2 places. So the average person gets, or every person gets an average of 14.7% off on their coupon. Which makes sense because everybody gets at least 10% off and some people get higher than that. So 14.7% sounds like a good number. All right, that was today's note-taking guide, you guys. Thank you for watching and good luck on your expected value homework.